All right, hello everybody. I want to apologize in advance if it sounds like I'm short of breath. It's just because I was just doing a three-legged race and a crab crawl walk thing with my son's Cub Scout thing. Anyway, I did have somebody take pictures and videotape the whole thing, so if you want to see the video, just ask me and I will show them in the class sometime before the bell rings. So if you want to see any pictures of Miss Pie doing a three-legged race, ask me tomorrow, okay? All right, so let's go ahead and get started with the notes. Find this page in your notes. We just have several different examples of different scenarios that you can have when you have a horizontal asymptote at y equals 0 here and vertical asymptotes at -3 and 2. If you notice, all of these have the same horizontal and vertical asymptotes, but there are several different possible scenarios that you can have. If you're below the horizontal asymptote, you're going to be like this, or you could be, if you're in between both asymptotes, you could have this curve, your parabola that's down here. Notice on the end values, it's like I don't know, what would you call it? An exponential function where it just kind of curves like this. In the middle, you get your little parabola. Or you could have a shape like this where it looks almost like a cubic function. Okay, so basically from this, these are just different samples of the different types of scenarios you can have with your rational functions and all your fun asymptotes. Okay, you also have the bottom half of that page where you have vertical asymptotes here and slant asymptotes. If you notice, every single one of these graphs have the same vertical and slant asymptote. And again, you can have a lot of different scenarios here. This one here is not a function. You cannot have that. The reason why is because if you draw a vertical line, let's pretend that's just a straight line. I'll make it straighter in 2 seconds. Hold on. Okay, so here's our straight line. If you draw a straight line and you intersect your graph in more than one spot, then it is not a function. It doesn't pass the vertical line test. Most of you should remember that test. All right, so, sorry. These are just different examples from this. You need to know that just because you have the asymptotes does not mean you know exactly how the graph is set up, but you can do some practice problems or plug in different values for x and see whether you're above or below the x-axis or above or below your vertical or horizontal asymptote. So what we're going to be doing in class tomorrow is a worksheet that looks like this. It's set up exactly the same. This is actually the first problem I put in your notes so you could figure out how to do it before you have to do all the practice problems. And if you have any questions, you can ask me in class tomorrow, or you can refer back to this page in your notes. Okay, so so far we've already learned that to graph your rational functions without a calculator, first you would set your numerator equal to 0. So to do that, you would just have x minus 1. Let me make this a little bit smaller. There we go. So in your numerator, let's see, where is it? No, I didn't. Oh, man, I thought I put the answers there. Okay, never mind. I know what I did. Sorry. So this is a lot of information. I'm going to take you through parts of it at a time, and we're going to graph it at the very end, okay? So here's the same information, just blown up a little bit bigger. So we first set the numerator equal to 0 and solve for x. So your numerator, you just set x minus 6 equal to 0. And the numerator tells you where your x-intercepts are, right? So in this case, when you set it equal to 0 and solve for x, you get x equals 6. Excuse me. Now you're going to do the same thing with your denominator. And the denominator, in this case, we'll have two factors, x minus 4 and x plus 2. And the denominator tells us where the vertical asymptotes are. And so we have two vertical asymptotes at 4 and -2. And we're going to look at both the the x-intercepts and the vertical asymptotes. If you have the same number in both places, then you would cross it off here and here and write it down as a removable discontinuity. Excuse me. In this case, notice we have 3 different numbers, so we're good. We don't have any removable discontinuity. So there's none of that. Excuse me. Then we need to look for our horizontal asymptote. And first, we are going to write down the degree of the numerator, and that is 1 here, and the denominator has a degree of 2. And in this case, our denominator is bigger than our numerator, so the rule tells us that your asymptote is at y equals 0. Because you have a horizontal asymptote, you are not going to have a slant or end behavior asymptote. In this case, you can either have horizontal or a slant or end behavior. You cannot have both. Okay, so on this graph, we know that our x-intercept is at 6, vertical asymptotes are at 4 and -2, and our horizontal asymptote is at y equals 0. Okay, those are the key things that we need to know. And now we're going to work on the bottom half of the worksheet. And in your notes, I know there's lots of lines on the side and everything. I do not use all of those lines. It just makes it really confusing. What I do is on my number line here, I put a mark next to each x-intercept and x next or where the vertical asymptotes are. Okay, and in this case, your horizontal asymptote is just at y equals 0. So here you would have dotted lines here, here, and you can tell I'm super worried about it. Okay, and we know that with horizontal asymptotes, our x-intercept is at 6, so 1, 2, 3, 4, 5, 6. We do a little dotted line there, or dot there for our horizontal for our x-intercept, and then we would have a vertical asymptote at 4, so something here, and then at -2. Notice I'm just doing one little dot for the asymptotes. Okay, so if I was going to figure out what the graph looks like without a calculator, I want to pick numbers on my number line. I need to pick one number that's bigger than 6. Okay, in this case, I can pick any number that's bigger than 6, but the bigger the number, the harder it's going to be to do all the math in my head. So I'm going to pick a whole number that's as close to 6 as possible. So in this case, I'm picking 7. I also want to pick a number that's in between 4 and 6. And again, I'm picking 5. And then I want to pick a number that's between -2 and +4. Anytime 0 is one of the options, go ahead and pick that number. Okay. And then I also need to pick a number that's less than -2. And again, whole numbers are easier to work with, and the smallest whole number, I guess, -3 would be the best option here. So I'm picking those values and I'm plugging them into the regular parent function. So, the original function. So here I replaced all my x's with 7s. This one I replaced all my x's with 5s, all my x's with 0, and all my x's with -3. So that's for each portion or each section. Notice my number line is broken up by my x-intercepts and my vertical asymptotes. Okay. When I do that, I'm just going to plug everything in. My numerator here, I get a 1. And then in the denominator, I have 49 minus 14 minus 8, and I get a 27 there. Here, my numerator is 5 minus 6, so I get a -1. And then in my denominator, I have 25 minus 10 minus 8. That should be 7. Okay? Those of you that are watching it, check and make sure I've done my math correctly. And then here, 0 minus 6 gives me -6. And then 0 minus 0 minus 8 gives me -8. Well, -6 divided by -8, that can be reduced to 3/4. The negatives disappear because they cancel each other out. And then down here, -3 minus 6 gives me -9 in my numerator. And then 9, watch your negative sign. So -3 times -3 gives you 9. -2 times 3 gives you 6, and you're adding. So 9 plus 6 is 15, minus 8 is 7. So I have positive number here, a negative number here, a positive number, and a negative number. Okay, so basically what I need to know is with my horizontal asymptotes, I need to know, am I going to be above it or below the horizontal asymptote? And remember, with horizontal asymptotes, you can cross them. Okay, so in this case, when my number is bigger than 6, I'm going to have a positive value, so it's going to be above the horizontal asymptote. Okay, right here I have a negative 7, so I know that I have a vertical asymptote here at 4, but I'm going to be going down. I know I'm going down because of my negative 1/7 here. I really don't care about the actual value. I just want to know, is it a negative number or a positive number here? And then down here in between these two sections, I have a positive number. So I know that my graph is going to be up here somewhere. And I know I have an asymptote here and an asymptote here. I don't know exactly where my graph is going to be, but I know it should be a parabola, something like that, because I'm going to be in between these two asymptotes there. And then the last section, I'm below the horizontal asymptote again, and so I'm going to probably be something like this, okay? Now realize I don't know exactly where the graph is, but I know the basic picture, okay? And then if I wanted to, I could go ahead and graph that in my calculator. Those of you that don't have calculators, don't worry about checking it. But if you did, you could check it and look at that. So, yeah, my shape, this little part here was slightly off. I was a little bit lower, and here I'm slightly off, but I still have the same basic picture. If I go ahead and erase all that, you can see that I have the same basic shape, okay? So in the exercise that we're doing tomorrow in class, or Thursday in class, depending on when you watch this video, you're going to have lots and lots of problems like this, where you need to analyze the x-intercepts, the horizontal asymptotes or slant asymptotes, and the vertical asymptotes and removable discontinuity. And then you need to be able to graph the basic shape without using your calculator, okay? I will probably not even have calculators out and available. Hopefully you can do this without a calculator, and then we'll check at the end of class, we'll check how accurate your results are, okay? All right, hope you fill out all the notes, and I will see you Thursday.